Hello and welcome to section 5.2 notes, verifying trigonometric identities. So the objective is just that, verify trigonometric identities. We've seen a few in section 5.1. Here I just want to insist on the fact that we have a format that we expect from students at KIS, and this is that you need to state which side you're starting with. So in example 1, we are starting with the left-hand side equal, and then you have to repeat what the left-hand side says. Secant squared x minus 1 over secant squared x. And then it's kind of a horizontal process to reach the right-hand side. We'll see how you can also write this vertically, but the first two examples I wrote them horizontally to really see how you're actually changing the expression into something equal, until you manage to reach the right-hand side. And this is what you have to do, just play with identities you know, simplify, etc., and try to reach the right-hand side. So this example, there's always many ways of doing it. What I did was I used the fact that secant squared x is 1 plus tan squared x. So this is what I got. Immediately I could simplify 1 and minus 1, so I got tan squared x over secant squared x, which simplifies to tan squared x times cosine squared x, because of secant squared x being 1 over cosine squared. And then if I write tan as sine over cosine, this is what I get, and I can simplify the cosine squares, and I get sine squared x, which is equal to the right-hand side. Again, there's certainly other ways of doing that. Any correct method is fine. The second example, tan x plus cotan x equals secant x cosecant x. I'm starting here with the left-hand side. I rewrite what the left-hand side is, tan x plus cotan x, and then I start working my way to try and reach the right-hand side. So here I am writing tan as sine over cosine. The cotan is cosine over sine, and one of the strategies we'll discuss later on, but it's important to realize that you always want to try and group different fractions together, so we are trying to have the same denominator. I need to multiply this fraction by sine x up and down, this one by cosine x, and this is what you get. Here I realize sine squared x plus cosine squared x is the Pythagorean identity. It's equal to 1, so I reach this point. 1 over cosine is secant, 1 over sine is cosecant, and therefore it's equal to the right-hand side. In example 3, we have to write secant x plus tan x and show that it's equal to cosine x over 1 minus sine x. So this time, that's important to realize that you can also start with the right-hand side if you want. If you think it's going to be easier, then just start with the right-hand side. Here, right-hand side equals cosine x over 1 minus sine x, and this time I wrote it vertically until I reached LHS. Cosine x over 1 minus sine x. One of the other tricks we will discuss here is that you want very often to multiply by the conjugate. It can simplify greatly your expression. So here we are multiplying cleverly by 1, basically. This is equal to 1. And what we realize is the denominator 1 minus sine x times 1 plus sine x is a minus b times a plus b. So it's a squared minus b squared. The top here, I kind of made a mistake. I distributed cosine. Cosine x times 1 is cosine x, and then cosine x times sine x. You can do that and just realize, like me, that it wasn't a great idea, but maybe we'll see when we do more exercises that often it's not a good idea to distribute. Anyway, we'll see what happens. 1 minus sine squared x here is cosine squared x, and now I realize I can simplify it by cosine, so I have this cosine simplifying. It's 1. Cosine x sine x is just sine x over cosine x. Now I'm breaking the fraction into two parts. It's 1 over cosine x plus sine x over cosine x. Here we are. 1 over cosine x is secant x. Sine over cosine is tan. So I reached the left-hand side. I'll just move back up so I can write equal LHS. Strategies. This is a very open little section here. There are many more strategies. Usually I just ask students for their ideas, but I just listed a few because I'm teaching this with a podcast. So some strategies are to use identities, factorize, add fractions together, multiply by the conjugate, start with the hardest side. Don't always start with the left-hand side, start with the one that looks the hardest, etc. You can find other strategies maybe. That is all, and I hope you will be able to do all the exercises with that. See you next week.